One question that comes up periodically when somebody first starts getting into cutting thicker materials is how do I get rid of this nib on the back of my part? This in this picture I believe is 1 inch thick stainless and obviously a pretty significant nib there. So the first inclination would be, well, I must not be cutting past where I let in enough, so therefore I need more over travel to make sure that the stream crosses over where I let in to help remove that. So generally the first step, which makes sense, would be to adjust the over travel distance, and in iGEMS you would go into your contour command, and depending on the lead that you're using, you'd click on your little edit button and depending on what that was, increase it 10, 20, 30,000, whatever you think might be enough to get the stream to go past where it let in. However, you actually end up fighting against yourself when you do that, and it's because we have to take a look at the characteristics of the water jet stream. So in this video of cutting some glass, we see the basic concept that that water jet stream at the bottom is going to be lagging behind where it enters the material at the top, and the faster you go, the steeper that difference is going to be, or the bigger that difference is going to be, and the slower you go, the more vertical the stream is going to be. So when you increase your over travel, you're fighting that, and then you also have to look at how we slow down when we come to the end of a cut. This white circle that I have here is supposed to represent the 40 thou water jet stream, and if I take a look at the code, basically going around the circle, we do most of it at 3.63 inches per minute, and then as we get towards the end of the cut we start slowing down, and we use a certain number of lines of code to get from the high speed down to what's being used for the low speed. And if we zoom in here a little bit, we can see that when we're crossing over the edge of the kerf width here from where we let in, so we would have let in here, and so there's no material here, and when the stream coming this way hits this point, the stream basically takes the path of least resistance, and that's where you see the stream essentially jumping the kerf at the bottom, leaving that nib of material. Now when you increase your over travel, as has been done in this part here, you essentially shift where we start doing the slowdown further and further past where we're going to be leading into the part. So by increasing your over travel, you'd actually be traveling faster and faster when you hit this point here and get more of a nib actually. So right now, for example, again we're crossing that nib doing about, or that area there doing about 2.17 inches per minute. If I go and I edit this tool path and I reduce that over travel, generally only need to use about 20 or maybe 30 thou over travel. And now if we take a look at the code, we'll see that now we start slowing down. So now we're 2.14, 2.44, 2.05, 1.77. We haven't crossed the stream yet, or we might just be starting to cross it based on the diameter. And then we're down to our low speed 1.5. So by actually reducing your over travel to something like 20 or 30 thou, it can help to reduce the nib. Now the other thing you can do is change the speed that you're slowing down to at the end of the cut. So to do that, we'd look into the material file, and this is what we use for the lead in and what we slow down to for the lead out. If you click on edit, you can adjust these numbers. So if you reduce that over travel number to the 20 or 30 thou and you're still getting nib, then you may need to slow down more at the end. I generally recommend slowing down if this cut is being done at the medium speed, which it is. It's got the 1.5 there. I generally recommend setting the low speed something similar to what the extra fine is. So I would set this low speed to 1.1, and then you'll see this changes orange to indicate that that's been changed, and then that again is what we'll slow down to. So we'll go ahead and take a look at this again. Here again we start slowing down. We're doing 1.8 to 1.58, so we might actually start crossing the curve at this point. 1.34, 1.1. So you can do that. Another thing you can look at adjusting if you need to, I would say speed is the primary thing after you've done the over travel speed. And then you can also look at changing this corner distance. This is how far from the end of the cut that we start slowing down. Also, when we're approaching a corner, that's how far from the corner we start slowing down. So if after dropping down the low speed, adjusting that over travel number, you're still getting some nib, you could look at, I would suggest first maybe doubling this number. So we could do 0.226, something like that. And then that will just give more distance to allow the bottom of the stream to catch up with the top as it slows down to that low speed. So we're doing 1.9, 1.5, 1.3 there, and then 1.1. So those would be the three things that I would recommend that you look at. Number one, over travel. Number two, the low speed. And then number three, increasing this corner distance. I've got some pictures of some tests that I did adjusting those parameters. This is a piece of 3/4 inch stainless steel, and we're looking at the back side of the part, and this would essentially be default parameters, and 1 through 4. I can pull up the spreadsheet that breaks this down. On 1 through 4 we're using 20 thou over travel, and then the low speed at the standard 100%, 80%, 50%, 25%. So you can see here the nib starts to improve on 5 through 8 using the standard ramping distance, a little more over travel. And I think you'll see here, especially at the default 100% low speed, a little bit more of a nib there. So even at 30 thou versus 20 thou, you're getting a little bit more nib. And then again, we're decreasing the low speed as we go along here. And then 9 through 12, we're using the back to the 20 thou over travel, and we've doubled our ramping distance. So here number 9, slightly better probably than number 1. Let's say number 10 here is a little bit better than number 2, and 11 and 12 look pretty decent. Let's see if I can get this position so we can see everything here. And then in the next batch, 13 through 16 in the this row here, we've got back to the 30 thou over travel with the doubling of that ramp down distance. And here you can see still a bit of a nib, maybe a little bit less than what we had initially. And then again, this improves as we go slower and slower with that low speed. And I think the best holes on the back side that we got were probably maybe these two, maybe these 4 here. So this would be 21 through 24 here. So in this case we're using 30 thou over travel, and this was actually basically had quadrupled the ramping distance from the default value. This may add a fair bit of time to your processing, so in that case maybe in the 9 to 12 range here with the doubling of the ramping distance, and then the low speed would probably be the way to go. So hope that helps. If you have any questions, let me know. Thanks.